All right, today we're going to dive into a really cool challenge. Can we take a totally ordinary, everyday object and use science to make it not just new again, but actually better than it was in the first place?
I mean, really think about that for a second. What if you could take a tool you love, one that's been with you for years, and give it a whole new life? A life where it's tougher, stronger, and works better than the day you bought it. Well, that's exactly what we're going to get into.
So, meet our patient for today, a simple pair of kitchen scissors. They still work, sure, but they're definitely showing their age. We're going to treat this like a real investigation, starting with a complete diagnosis to figure out exactly what's going on. Okay, here's our case file. We've got the basic stats, length, thickness, all that. But the key detail is the material, a common stainless steel. Now, we did a little test and found it's only weakly magnetic. And that little detail, that's our first big clue about what kind of steel we're dealing with. This isn't just random data, this is the groundwork for our whole plan.
And boom, there it is, the smoking gun. This observation from the case file says it all. Those abrasive wear tracks, you can just think of them as tiny scars from being opened and closed thousands of times. The hinge is the heart of the scissors, and it's where all the stress is showing. That's the spot we need to fix.
All right, so with that diagnosis, it's time to talk treatment. The cure we've picked out is a process called hard chrome plating. Basically, we're going to give our worn-out patient a custom-fitted suit of armor. And this slide right here shows you exactly why we do this. It's a total night and day difference. On the left, you've got the original blade, which gets scratched up and can even rust a bit. But on the right, with that chrome coating, you get incredible wear resistance, way better protection against corrosion, and just a smoother cut all around. We're not just fixing the wear and tear, we're giving the whole tool a major upgrade. Now here's the number that really tells the story, 900 HV. That's its Vickers hardness value. To put that into perspective, the original steel is only around 500 HV. So we're talking about a coating that's nearly twice as hard. This isn't just for looks, it's a super tough shell that's going to make these blades last so much longer.
So you might be wondering, why hard chromes specifically? Well, for one, it works great on this kind of stainless steel. The blades are flat and simple, which makes it easy to get a nice, even coating. And it's perfect for treating that high-friction hinge area we identified earlier. Plus, there's a nice little environmental bonus. A longer-lasting tool means less stuff ending up in a landfill.
So, diagnosis? Check. Cure? Check. Now it's time to scrub in and head to the operating room to see how this whole delicate procedure actually works.
Now you can't just slap the chrome on. No way. The prep work is absolutely crucial, and it has to be done perfectly. First up, you got to get them clean so they're completely degreased. Second, they get sanded down with superfine grit paper to get rid of any old scratches. Third, they take a little acid bath, a process called pickling that gets the steel surface ready to bond with the chrome. And finally, the plastic handles get carefully masked off so they don't get damaged.
And to give you an idea of the kind of precision we're talking about, the goal is to apply a layer of chrome that's just 20 micrometers thick. How thick is that? It's about the same as a single strand of a spider's web. It's this incredibly thin, almost invisible layer that provides all that new strength. Amazing, right?
But this is a complex operation, and things can definitely go sideways. If that surface prep isn't flawless, the chrome can just peel right off. If the electrical current is too high during the plating, you can get what's called edge burning on the tips. And here's a weird one. The process often creates tiny microcracks. Now, sometimes that's actually helpful because they can hold oil, but it's still something you have to manage very carefully.
So this all sounds amazing, right? We've got this incredible process that makes our old scissors tougher and better than ever. It really seems like the perfect fix. Or is it? Because this cure, well, it comes with a cost, a really big one.
Yeah, there's a dark side to this miracle cure. And it's all because the main ingredient, the chemical that makes this whole thing possible, is some of the most hazardous stuff used in industry today. It's called Chromium-6, or as you might see it written, Chromium VI. You'll also hear it called hexavalent chromium. It's the key ingredient in the plating bath, and let's just be blunt about it, it's a known human carcinogen.
And we're not talking about a small risk here. This stuff is no joke. Exposure can cause cancer, it can do severe damage to your lungs, and it can literally cause corrosive burns on your skin. What's worse, the plating process itself can release it into the air as a fine mist, which means you need extreme safety measures to keep people from breathing it in.
The risks are so bad, in fact, that governments all over the world regulate this chemical incredibly tightly, As you can see here, major agencies like OSHA in the US and REACH in the European Union have this stuff on their highest alert lists. The amount you're legally allowed to be exposed to is just minuscule.
So this brings us to the big final question. On one hand, we have a process that can give a tool a longer, better life. But on the other hand, we have a process that's a serious danger to people and the planet. So, was it all worth it?
I love this quote from the original source. On the surface, it sounds like a purely technical problem, right? Getting that chrome layer just the right thickness. But it's really a perfect metaphor for this whole story, isn't it? Every single choice in engineering and manufacturing is a balancing act, a trade-off.
And that's the ultimate trade-off right there. A longer life for the tool we use versus a risk to our health and our world. This story isn't really about a pair of scissors, you know? It's about almost everything we make. We have the technology to build things that last, but that durability often comes with a hidden price tag.
Which leaves us with this final, really tough question to chew on. We have the power to engineer incredible durability, but with that power comes a responsibility to be smart about it. And it forces us to ask ourselves, when is making something last longer simply not worth the cost? It's definitely something to think about.